Good afternoon.
And your
Good
slides.
afternoon, everyone. Sorry. Good afternoon, everyone. My name is Nicholas Sen, and my topic of the study is on shopping behavior analysis with data analytics tools. We all need to buy groceries. I chose this topic in the hope that the analytics help everyone in the community, both the stores and the customers. And as some example, our findings help the store on planning what products to stock up, how to schedule staffing, and our findings also help customers on what is the best hour to go shopping to avoid crowds. As a term definition, shopping behavior analysis is the process to gather and analyze data on shoppers' actions, then identify their buying patterns and preferences. As for the motivations for the study, stores need analytic insights to make business decisions to stay competitive. We certainly do not want our local favorite stores to go out of business. Customers want convenience, abundant products to buy, and efficient shopping. We want to help our community for retailers to sustain and stay profitable, and for customers better shopping experience and improve quality of daily life. One more reason. Working part-time in the supermarket, I care and I want to help both the customers and the stores. Last but not least, there is an abundance of massive open data sets. The data set used in this study is a Turkish market sales data set. It is a supermarket data downloadable from Kaggle. The set contains more than 9,000 supermarket items, over 600,000 sales records. It includes 52,000 unique customers, including the name and gender. And the data is collected from over 81 stores from January 2017 all the way up to November 2017. A small note on transaction data. Stores entice customers with a membership reward for programs. And in return, stores gain the customer data from the name, the address, the age, the gender, phone number, etc. Shoppers swipe member cards at the checkout, and bam, transaction data is captured with product spot, price, quality, quantity, etc., along with the customer information. These kinds of transaction data is what was in the data set we use. Now, what are the areas we want to gain insights? Well, you want the answers like which products sell more than others? What are the busier shopping hours during the day? Do some items sell more based on the gender? Do some items sell more at certain hours of the day? And if people do not buy certain categories, what are they more likely to buy? For how we carry out the study, we first select a data set containing supermarket transactions. For data management, we use an Oracle database and create tables in the database to load the data in for quick, reliable access. We then wrangle and clean the data set, and then we translate key textual data elements from Turkish into English. We then aggregate transaction timestamps into hour buckets. We then develop SQL codes to enhance the data set. We derive the categories rankings based off the sales volume, then derive the transaction hour rankings based off the sales volume, and then using inline views, we join the rankings back with the original data. For the technology and tools we use Oracle database as the data management system, and SQL Developer for data wrangling and analytical queries. In terms of the approach, we start with the questions and hypotheses. With some questions, we can begin with the intuition and prediction. For example, some stores are busier some hours than others. With most other cases, we can only get answers after the number crunching. For example, which product sells the most, the second most, etc. We develop and apply code logics to the data set. Once we obtain the statistical results and present them in charts, we can analyze the characteristics of the charts to derive the trends and patterns. We interpret the findings and provide insights. We also discuss how the insights can help stores and customers. Exploration of the derived patterns sometimes reveal more interesting facets, which prompt us to continue the study further. For example, tobacco purchase patterns. For our findings, naturally, we expect some products to sell more than others. But which one sells the most, the second most? We carry out our analytics to derive the sales ranking by the category. Results are shown right on this very chart. We see our intuition is validated. Yes, some products sell more than others. The number one sales category are staple foods. Number two is milk and cereals. Now here are a few more interesting findings. The top 5 categories, staple foods, milk and cereals, beverages, produce, and meat and poultry are all what we eat and drink. Not that surprising as we are studying supermarkets, not department stores. The milk and cereal sales is quite significant as ranked number 2, way more than number 3 and number 4. I find this interesting. It might be because simple breakfast is very popular. Beverage and produce sales are fairly close. This may be also be interesting to some. Findings like these can certainly help retailers plan on what to stock up next. We have all been to different stores at different hours of the day. Our hypothesis is that there are hours that are busier than others. Here are the results of sales volume over the hour of the day. Yes, we confirmed our hypothesis. We see distinct peak hours. The busiest hours are between 12 noon and 8 o'clock of the evening. We also find that roughly 80% of the sales volumes happen within these 8 hours. The rest of the 10 hours those account for only the remaining 20% of the sales. Furthermore, the busiest hours are between 5 o'clock and 6 o'clock in the evening, which may make sense. It may be because commuters are shopping on their way home during these hours, or it could be those last-minute shoppers prior to cooking dinner. These insights of when stores are busy are also valuable, as it helps stores plan on when to schedule more staff, and it helps customers to decide when to go shopping to save time and avoid the crowds. Remember when the first chart when we learned that most shoppers buy the staple foods and milk and cereals as the top 2 categories? Out of curiosity, for those who not buy these 2 categories, what are they going to the store for? Our result is shown right on this very chart. And to my surprise, they buy tobacco products. And in ranking order, tobacco is number 1, beverages number 2, produce number 3, etc. They should have a different buying patterns compared to what general shoppers are shown in the first chart. As for business insights, stores may not want to get rid of tobacco products. There are customers coming to the store with tobacco being the main reason. Gender is an important dimension to study. We derived the sales volume across categories for both male customers, shown in blue, and female ones, in orange. What we learned is that male and female customers have similar buying patterns across the categories. For example, all buy staple foods as number 1, milk and cereals as number 2, etc. Women buy more than men in every category, with one exception. Men buy more paper products than women. I'm not sure what the reason is, but it could be perhaps toilet tissues are more bulky and end up in men's shopping lists more than women's. Or the data set of paper products may not be large enough for statistical conclusion. In any case, further study is needed to validate this exception. As for the business insights, store marketing may tailor to a certain gender to help for more sales. Continuing on the interesting finding that men buy more paper products than women, we want to see the distribution of sales across the hours. The result shows a distinct spike at the 11 o'clock hour, just 1 hour before noon. This is very interesting. Not only are male customers buying more paper products than females, They also buy a lot more during the hour just before noon. Could this be a data anomaly? Some patterns may not have an easy interpretation. We may need more study to validate this finding. In conclusion, our analytics provide insights valuable to both stores and customers. For example, the insights help stores plan on stocking and staffing. They help customers decide when to go shopping, especially during the pandemic, where the vulnerable population can steer away peak hours to avoid crowds and stay safer. Ultimately, the analytics help stores, sustainability, and improve customer shopping experience and quality of daily life. As for future study, I'd like to expand the dataset to build predictive models or recommender systems based off items purchased. As part of a community engagement, I make myself available for working part-time in a supermarket. I make conscientious efforts to encourage customers to check out the swipe member card. A small part of my contribution to data science community to gain more data points, because the more data collected, the better we gain analytical insights, and the better we help shoppers and stores, the better we serve the community. I'm glad that the work done with this project helps the community and makes a positive impact. The code base and wrangled datasets are available to the public on GitHub. Thank you. And any questions?
Any questions for Nicholas, please? Perhaps the panelists?
Sure, I had a quick question. I noticed that I think that the location, the supermarket location data was in the data set. Is that correct? Or
Yeah, it is.
did you use this to, I don't know, do any of your analysis? Was this part of the analysis in any way? Perhaps like rural areas versus metropolitan areas, kind of to kind of understand buying patterns for different localities?
Admittedly, I did not, Professor, if I'm going to be honest.
Okay, sure, no problem. And I guess my other question was about the kind of the selection of the data set. Maybe you mentioned this at the beginning when you were talking about the data set, but what were some of the things that drew you to use this particular data set?
I'm not sure. Maybe because I feel like I can. Maybe because it might be most interesting to use this data set in particular.
Okay, great. Thank you.
Thank you. Any other questions for Nicholas, please?
Yeah, I have a question. It seems like from your data set, you've drawn some insight about sort of like market inferences we can make about market spending or something like that. I'm interested in the application area. Do you think this is better suited for a particular store, gathering this sort of data and making inferences for their particular score? Or do you think this is better suited for like looking at the market as a whole between many stores?
I'm leaning towards the latter statement.
All right, thank you.
Thank you. Any further questions, please? Okay, I hope that I'm not interrupting anyone. I suggest we wrap this up and thank our last speaker for today, Nicholas. So at this point, Scott, if you